You can't even feel my stare. Oh, I try, I can do the shit anyway. So, cash in hand, we ain't got no time to play. Oh no, no, I can't do this alone. Oh no, no, I need that evil dojo. Oh no, no, where the fuck are you, dark mage? Oh yes, baby, I need that evil dojo. Hey you, I've been looking for you everywhere. So cold, you can't even feel my stare. Oh, I try, I can do the shit anyway. So, cash in hand, we ain't got no time to play. Oh no, no, I can't do this alone. Oh no, no, I need that evil dojo. Oh no, no, where the fuck are you, dark mage? Oh yes, baby, I need that evil dojo. Oh no, no. Oh no, no. Oh, oh, no.
You are now listening to Evil Dojo Dark Mage in the house with the sick flow. You are now listening to Evil Dojo Dark Mage in the house with the sick flow. You are now listening to Evil Dojo Dark Mage in the house with the sick flow. You are now listening to Evil Dojo Dark Mage in the house with the sick flow.
Is this thing on? All right, we're good. So I did some work on the dungeon generation algorithm off stream. It did not take much. That's almost fully connected. Unfortunately, to like at the moment test individual parameters, I kind of have to manually change certain variables in certain locations. Like for instance, the one you just saw was on a 64 by 64 tile dungeon, and like we should probably make a mark to like hop back and forth. Oops, I didn't mean to go there. So let's set a mark like right here, and then also right here. That way I can hop back and forth between these two parts, because the idea being we want to be able to size the width and the height of the dungeon to any sort of multiple of like 8 and have the algorithm correctly conform to whatever size dungeon floor we happen to be working with. So as an example of this, and actually probably in an it dungeon itself, we probably want to have varying floor sizes possibly. But the point being, we have this variable called parts, and parts is what we use to divide up the dungeon floor into certain sections. So an 8 by 8 wouldn't make any sense with 8 parts, right? So generally speaking, parts should be greater than 1 in order to have multiple rooms throughout the dungeon, right? So like as an example, let's set this to like an 8 by 8 and see that it generates like 4 rooms that are all connected. I think music off is only music offing for like the first loop, and then somehow like starts playing. One, two, three, 4, right? 1, 2, 3, 4. 1, 2, 3, 4. So we're getting a really nice pattern there, right? So if we want to scale it up to like 16 by 16 and maintain 2 parts, now we should still have 4 rooms, but they should be a lot bigger. One, 2, 3, 4. One, 2, 3, 4. And so for this very simple case, things appear to be working. So if we scale it up to 32 by 32, we'll still have 4 rooms, but they'll now be even bigger still. But notice that the distance between rooms is increasing as a result of this. So interesting, no connection there. There's our second room. 3. Ah, that's why. And then, so now we have a situation where we have managed to generate a dungeon where not all of the rooms are connected. And so this would be where I would want to implement a secondary pass algorithm that goes through and attempts to stitch up any sort of like things like that. As an example, we might even have a filter that checks to see if certain tiles match certain conditions in order to determine whether or not we want to generate an additional tile there. So we'd go through like the whole dungeon tile by tile and look for situations where that might be appropriate, right? So in this case, we would definitely want to create like an additional 2 tiles in order to connect this room up to this room. But we would do so on kind of an agnostic tile by tile basis, without really considering that like there is even a room there to begin with. Now the trick with this is that this first set right here would immediately match that condition. So it'd probably be this first tile here and then this tile here that ends up getting set in that algorithm. So with the bigger dungeon floors, there's a chance that things don't necessarily get wired up properly. See, in this case, it looks like the same thing happened. We have a situation where now we have one tile that needs to be connected to that tile in order for everything to be stitched together. And so we want to be able to do things like mark that tile by stepping through every single tile and finding that one tile there that matches that condition, where the tile above it is black, the tile below it's black, and it's got 2 non-black tiles, one to its left and one to its right. And so this tile would want to mark as a good candidate for fixing, right? But otherwise, I'm happy with the results, because check out what we can do. We can actually change parts now from 2 to 4. So now we have a 16 by 16 grid within this 32 by 32 area. 4, 8, 12, 16. No, sorry, 8 by 8. So now we're going to have up to 64 rooms, if my math is correct. Or wait, 16 rooms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So it generates all the rooms, and in this case, we have no tile or no rooms that we are unable to get to, which is good. You want to have a dungeon that you can navigate the entirety of without having any sort of islands or rooms that are inaccessible from any other part of the dungeon. So in a similar way to how we would want to stitch up situations, like for instance, some of these tiles would fall into that category, so they could be marked for potential stitching as well, in order to create like a link between this dead end hallway and this room here. Which that would be kind of the goal, is to make sure that things are stitched together, because the idea was that every room would have potentially more than one exit to begin with. Eventually we'll get to a point where something's a little bit more upgraded. In a little bit, we'll take a little potty break, and then I want to get doors back in, right? And part of the problem with doors here is that realistically, we only want like one door in a hallway, right? We don't want necessarily situations where we have a door here, 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 a door here. That's ridiculous. So figuring out like appropriate locations to put doors and how to actually place them is going to be important. Previously had a very naive algorithm to help identify good door locations. But realistically, like, it would make sense in the most liberal sense to have a door here and then to have a door here. So you have space in the hallway where you're in between two doors. And that would make sense. Similarly, we also would want a door here as well. Now, when these hallways are being created, they're being created from the center of a room. So for instance, it goes from here to here when it's marking tiles. But if we had a way to adjust it so that the hallway gets generated only from the edge of the room, then the beginning of that hallway ends up being a great location for a potential door, right? And ideally we aren't like spamming like tiles to be marked as potentially good locations for doors. We use something that's very intelligent in how it's placing. So if we can mark those locations during initial generation, then we can just sweep through and add the doors in the appropriate spots right out the gate. So if it's like one door per hallway, or rather 2 doors per hallway, all we have to do is update how we're generating hallways. And so long as we can maintain the correct generation, then we can actually get some doors cooking. What's up, 10x developer? I like the name. Good username. Place doors literally goes through every spot in the dungeon floor and checks to see if the tile has a variable set called get can have door. And if it does, then it creates a door there. Very straightforward. So in our dungeon creation loop, right here. So here we create rooms, and then we set rooms, and then we create the hallways. Here we calculate the center of room, right? Now, if we take like half of that, rather, what we're initially doing is we're calculating the center. But if we instead calculate an edge, that is, when actually going to set, like, for instance, the horizontal hallways along the x-axis, we grab the calc center x of room 2, right? Calc width of hallway. Now, all we have to do here is adjust these parameters in these cases, right? So for instance, to calculate the edge of room 1, right? We're going to take Rx, and actually, and it's just going to be the x of the room plus the width. So if it's a 4x4 room at position 0, 0, then this x will be 4. So it'll be one tile after the room. And we can leave ry as it is. But then, in addition to this, what's up, CBOXIO? So calc edge of room 2. This is going to be RJXE, which is not going to be the center, right? And it's not going to be plus width. Actually going to be x minus 1. So now using that edge, now the new width that we calculate is RJXE minus RXE. And that should be correct. So it'd be a similar sort of transformation for the vertical hallways. So RJYE in this case, and RYE. So this is actually going to be height, right? RJYE. then or rye, and then rjye is going to be a similar thing. Also, this doesn't have to be 2. That could be just that. So now the height is going to be rjye minus rye. Oh, and the rectangle, we got to fix the rectangle here too. This is going to be rxe to ry. Oh no, riy. Wait. Yeah, so that's gonna be rxe to riy to rw and 1. Then down here it's gonna be rix to rye 1, and then ooh, almost. Looks like the width of the newly generated hallways needs to be increased by 1. Oh yeah. Huh. Oh wait, and then ry. We need to fix this one. This one is also. No wait. So rjy actually needs to be y. Looks good so far. And well, it did what I wanted mostly. I mean, algorithmically, it followed my orders, but there is definitely some work to do here. So this would definitely be a case where we'd want to connect this tile up with this hallway. We want to connect this tile with that hallway. Connect this tile. Connect this tile. Set those two tiles. That tile. But otherwise, not a bad stab at it, right? Now, notice that the problem is only with the last tile in the sequence, not the first tile. So the first tile might actually be a good place to mark for having a door, right? So if we go to set an area like this, then we can grab like a first tile. Let's see if everything comes together, because we haven't placed doors in a while. Yes. Okay, let's turn God mode off. All right, let's start by navigating our surrounding environment. One thing that would be useful is if you've seen a door, if like the door stayed persistent, but like as it is, you don't actually see the door until you walk past it. But it would be kind of cool if, like, once it's out of range, if, like, you still had a memory that, like, the door was there, right? That's a potential upgrade. Interesting. Empty room. Yeah, so there's another situation. I mean, it's expected based off of how things have been working so far. Looks like we met, huh? Let's go navigate over there to see if we can get to those rooms. Yeah, exactly. NetHack was a fucking huge inspiration for this game. Can't tell you how many countless hours I played NetHack and operating systems when I was in college, man. Okay, this is not bad. This is not bad. So I want to introduce a one-pass algorithm to help connect these rooms up a little bit. Essentially what it'll do is, for every single tile in the dungeon floor, check to see if its neighbors occupy a certain state. So starting from like 1-1 all the way down to like width -1 and height -1. So that way we don't have to deal with the edges. It's more often than not. Well, no, that's not true on the small maps. But even still, for the pass algorithm, right? Let's check this code in. And even then, if we like simply picked a spot along the hallway to generate the door, that would also be good. But I think it's also good if the doors are at the beginning of rooms rather than like in the middle of the hallway. But either could be an option. It's going to be pretty soon. We're going to really need to get pathfinding back in, man. All right, one pass algorithm, right? So we create rooms, we set areas, we stitch up hallways, and then we're like, oh, fuck. Wait. Okay, so we're going to use a function similar to this. Tile is good for upgrade. I don't know what else to call it right now, but it does a lot of like what I initially set out for, which is to grab the surrounding 8 tiles, right? And then certain conditions, if they're true, can be used to determine whether or not we want to actually upgrade this tile. So as an example, imagine we have like hashtag, 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 hashtag. So imagine, if you will, that we have a situation like this, where we have like a room on the right and a room on the, or like the edge of a hallway or something on the left. So this would be a perfect situation where we would want to link 2 rooms together. Another one would be 2 edges of a hallway like this. Another one would be a full room, or even a room like this. So you see, we have all these different like patterns and arrangements of 9, you know, like 3x3 tile sections, where if we do checks on each of these tiles, each of these neighbors, and determine that the conditions are satisfactory, then the center tile can get upgraded to like a real floor tile. So let's implement a kind of hard-coded example of this. So location X and location Y correspond to the center tile. So we don't really have to think about like the location so much as which tile we happen to be checking. So 0, 1, 2 corresponds to it's like it's like 0, 1, 2, 3, 4, 5, 6, 7, like that. So we just have to keep in mind the order that I happen to write this. So, and I could always rearrange it. I'm not going to take the time to do that. Imagine that we wanted to take like a look at tile 0, right? And let's say it's equal to tile none. What about tile 1? Or rather tile 3? What about tile 5? So if the top row is all none, and the bottom is all none. And what about 1 and 6, right? Ew. What an awful check, right? So let's break this up. And then we also want to check bottom row, right? It's already starting to look a little bit better. But if all those are satisfactory, then we can return true. So this would effectively be like condition 1, right? So it's a lot easier to manage because we're going to have a lot of different Boolean checks like this, where we effectively sweep through all of the different tiles to see what situations make sense to actually upgrade this center tile from like an empty to like a real tile. So let's work with this as a basis to start with to see how we would integrate it into our generation algorithm. So like right here, for instance, instead of actually doing tile at like this, we could actually just check to see if tile is good for upgrade. So if df pointing to tile is good for upgrade of something like this, Actually, we don't even have to grab the tile. We can do set and then for our rectangle, what? Oh, it's a df set area. It would just be a good opportunity to actually fix that. Oh yeah. So let's give it a shot. Oh, interesting. So this one didn't get stitched up. That's okay. But a lot of them look pretty stitched up. Definitely a step closer. So while we don't necessarily need to grab the tile at that location, we could actually do that and mark it as a door right out the gate. Oh no. Oh no. It created so many doors there. Why? Oh, it did it again. Oh, lame. That's so funny. It's exactly what I was trying to avoid. And that, not only that, but it didn't even connect that room up. That's so silly. It didn't even... Oh my god. Yeah, it's not going to connect those rooms up, obviously. I want to experiment with setting a last tile. Oh, hey, okay, that's reasonable. Even though the rooms were, like, right next to each other. Oh, that's interesting. Although this door is really not functional. Yeah, that works. Not bad. That's not terrible. Not a bad start. Hey, shield. There's the axe. Not bad. Not bad. Not bad. Not fucking bad at all. Put some boxes in. Uh-oh. Not picking up the game again. There we are. Oh, nice. We got a box in a hallway. Oh, that's going to be fun to deal with. Oh, right. Another box in a hallway. Fucking awesome. Oh shit, really? I hope those, I mean, they are gonna get in our way. So I'm gonna have to be more far more intelligent about how I'm actually marking like rooms, because we probably don't want to spawn objects in hallways, right? So we're keeping track of like room data. So we should be able to limit the space where something generates by specifying like an area and then generating a random location in that area. So that's something I'm gonna have to handle. We're lucky we can navigate around this. We got very lucky with the placement here. Here's a good example. So we can't navigate around this. Right. So that's something I'm gonna have to fix. But I figure create some boxes in there, you know, push the limit, see what we can really do here. Hey, cut it out, Nano. Fucking cat clawing up my computer. Right, well, this is actually really strong checkpoint. We should probably keep this one an early session. Take some time to really think about next steps, because there are some details that I want to work out, such as like whenever an entity is moving into a shadow tile, it kind of appears like they just disappear at the moment. The movement transition for that particular state is not super fantastic. Plus, there is the thing with the doors that I mentioned earlier. Plus, I have to piss. So I'm going to go and count this as a win. Thank y'all for joining today. As usual, always a pleasure. More to come. Plenty more to come. Until next time, everyone. Evil Dojo signing off.